Hello everybody. Hello and welcome to the webinar session of today. We are now going to start this session about the Gait Deviation Index and the Gait Profile Score, which are two widely used and popular measures about the overall kinematic deviation. Those two indexes can be now easily got by the gait analysis protocols included into the BTS SMART Clinc application. We can say that three-dimensional instrumented gait analysis is widely recognized as a central element into the quantitative evaluation of the gait pattern for patients with movement disorder. Gait analysis provides objective data useful in clinical practice to define the level of functional limitation, and we can say that it's nowadays a gold standard for the treatment planning, treatment optimization, and follow-up. Gait analysis can provide objective information about 3D joint motion, spatial temporal parameter of walking, 3D joint moments and power, EMG, and so on. So a typical 3D gait analysis produces a report with a large amount of data, and sometimes it can be not so easy, let's say, to have a global comparative overview of all of them. Also because of the interdependence and the correlation of the analyzed variable. For this reason, in the last year, some indexes have been developed, which could be useful to summarize the overall deviation of the patient walking pattern from the normalcy. These are the goals of both the Gait Deviation Index and the Gait Profile Score we are going to talk about. As I told you, for the reason discussed on the previous slide, over the years several multivariate gait indexes have been introduced as means as assessing the overall outcome and the gait pathology. For example, the GGI, developed by Shuttle and others in the 2000s, represented the first effort to join all the information coming from the gait clinical report into only one index. On the 2000s, was also developed the hip FLEXOR index coming from Michael Schwartz. The Gait Deviation Index and the Gait Profile Score from, again, Michael Schwartz and others are the most recently developed, and those have been implemented within our Gait Lab protocols available in SMART Clinc. The NORMALCY index, or the GGI, developed on the 2000, is derived from 16 discrete gait variables, which describes the way of walking of the patient and measures the distance between the patient's gait data and that of a control population with no pathology. The used variables are in this case 3 temporal parameters, which are the 2 of time, the walking speed, and the cadence, and 13 discrete kinematic variables like the mean pelvic tilt, the range of the pelvic tilt, the mean pelvic rotation, and so on. On the slide here, you can see the list of all the used parameters for the computation of this index. In general, we can say that the 16 normal parameters create like a 16-dimension space where in its origin is the normal reference. So, depending on the values of the values of the 16 parameters, we can establish which is the position of the patient in this space. The NORMALCY index, or GGI, is so computed as the distance of the patient from the origin of this 16-dimensional reference system. We can say that the higher the functional limitation of the patient is, the higher the index is. So, we can say in general that the GGI index is quite popular, but it's a little bit dependent on the variable chosen to compute the index, that are considered to be a little bit too subjective. Another example of index was the hip FLEXOR index, that is dedicated to describe not only the overall gait pattern, but only the hip function. It uses 5 variables. So the maximum peak of the pelvic tilt, the range of motion of the pelvic tilt, the maximum of the extension in swing, the percentage during the stance when happens the inversion of the flexion extension moment, and the peak of the power. It's the only index that uses both kinematic and kinetic parameter, but is just devoted to the hip joint and not about the overall gait function. While the GDI index, developed by Schwartz and Rosamulski on the 2008, it's a sort of, let's say, reprocessing of the previous NORMALCY index or GGI. It doesn't use any temporal parameter, but it takes in consideration only 9 kinematic variables. The used variables are 3 pelvic angles, so the obliquity, the tilt, and the rotation, 3 hip angles, so the abduction, the flexion extension, and the rotation, 1 knee angle, that is the flexion extension angle, and 2 angles for the foot, so the dorsiplantar flexion and the foot progression. The GDI doesn't extract only some discrete values from these graphs like the NORMALCY index, but it samples the graph with a rate of 1 sample every 2% of the gait cycle. So it considers 51 values for each graph. And globally, we can say that it considers 51 values for 9 graphs, so a total amount of 459 values are considered. This method of comparison aims to reflect the extent of gait variation with respect to the controls. So a GDI value close to 100 or higher indicates the absence of gait pathology, and each 10 points of decrement below 100 indicates 1 standard deviation from normal kinematics. For example, if you get a GDI of 65, means that your patient is 3.5 standard deviation away from the normalcy. This is about the GDI. While the gait profile score, that is the other index, summarizes the overall quality of a patient kinematic gait, as is for the GDI. But in detail, from a mathematical point of view, this index is the root mean square difference between the patient data and the average from the reference dataset, taken over all the relevant kinematic variables for the entire gait cycle. So, as the GPS represents the difference between the patient data and the average from the reference dataset, we can say that the higher the GPS value is, the more compromised the gait pattern is. But in addition to the GPS index as a global measure of the overall gait quality, like the GDI, this index can be also decomposed to provide the gait variable score or GVS that are each of one is an index that measures the single gait variable deviation for each of the 9 key relevant kinematic variables used for the creation of the index, which are the pelvic tilt, the pelvic obliquity, the pelvic rotation, the flexion extension, and you can see the list of the variables used on this slide. In this way, it's possible to look at inside the global value, thus providing detailed information about which variables are more contributing to an elevated GPS respect to the other. So we can have a better comprehension about this. So in general, we can say that many studies, a lot of research articles have been published about the application of those two indexes in order to quantify the patient functional limitation during gait or the outcome of specific treatment. And it has been established that they are both significant not only for CP patients but also for other pathology. So on this slide you can see some of the available paper, but if you look at in internet or in PubMed, you will find a lot of publication. So now let me show you about how to use these two indexes within our application. So what to do? This is the SMART Clinc database. The first thing to do is to load one standing and one walking trial. The first thing, as always, is to perform the tracking of the data that you have recorded. This is the standing. The auto-labeling will be performed automatically, as you can see. The next trial will be the walking trial. Also in this case, the auto label will be launched automatically. Okay. So after that you have tracked the trial, the next step is to run the protocol. So you can choose the proper protocol to run the GDI from the one available within the list. Now I'm going to select the Devis plus the GDI, and the next step is to select the table which contain the normative data. You have different options depending on which is the age of the patient. Now I have selected the GDI young, depending on the age of the subject that I am going to analyze. This data consider that come from a normal patient. Now the next step is to define the gait cycle. Now I'm going to define the right foot strike. So this is going to be the first. To do that, you can move the stick diagram and choose which is the frame which define the event. Now I'm going to define the second right foot strike. Okay, as you can see, the vertical bar represents the event, the desired event. Now I'm going to define the third right foot strike. So at the end we will get information about two entire right foot gait cycle. Okay, so this is going to be the next right foot strike. Okay, now I click OK, and the next event that we will have to define will be the right to off, so the to off of the foot. Again, to do that, you can scroll the trial, and you can click with the mouse on the events which represent the desired event, in this case the to off for the right foot. This is going to be the second one. Okay, to help you in doing that, you can zoom in, look at the stick diagram, and if you have the ground reaction force, it's suggested to use the information coming from them. Now I'm going to define the event. Okay, so it's the same for the left heel strike, sorry, left foot strike. Okay, this is the first heel strike, foot strike. Okay, and now I'm going to define the second one. You can move frame by frame to choose the desired event. Instant. And now I'm going to define the third. So at the end, also for the leg, we will have two entire gait cycle also for the left side. The next event that we have to define is the left to off. In doing that, you can also help yourself by looking at the two graphs which are represented on below, which represent the knee flexion extension angle, that is the one represented in blue, or the ankle dorsiplantar flexion angle, that is the one represented in red. If you want to modify that, you can do it by modifying the protocol and choosing the desired variable. Okay, I'm now going to define the last left to off. Okay, after that you did it, the next step is to save the processing, and so the file will be loaded within the list of the trial available to get the report. Okay, so now the process is going on. Okay, now it's finished, so I'm ready to click on Save, and that's it. Okay, so now that the two trials are loaded within the trials available for the report, the next step is to select the desired trial and to select the desired report that you want to use. Now I'm going to choose one of the available one which contain the information also about the GDI. And the next step is to select the desired normative band. In this case, I'm going to select the one for the adult. Okay, so as soon as you click on the button, the two trials will be automatically loaded within the report. As you can see, this is the standard report. So on the first page you have the spatiotemporal parameter about the gait, and on the second page you have the information about the consistency, about the right kinematics of the joint. On the third page you will have the same about the left side, and on the last page finally we have the information about the mean 3D kinematics about the right side versus the left side, and there you have, as you can see, the information about the computation of the GDI. So this is a normal subject. So as you can see here, the value that we get concerning the GDI is a value that is higher than 100. So in this case, for this subject, you have a value that is more or less around 105, 106. Okay, and here you can also have a look at the graph, and as you can see, they are very, very close. They are perfect, so they are absolutely normal and comparable to the normative band. Now let's have a look about how to run the GPS. So it's almost the same. So you have to consider one standing and one walking. You have just to select in SMART Clinc the protocol which included the computation of the GPS in this case, and you have to select the table which contains the normative bands. Okay, so now the next step will be to define the events of the gait cycle, but we already did it during the previous processing. So as you can see, the events have been already defined. So what we have to do is just to check that they are fine, and if we agree with the identification of the desired events. Okay, so now this is the left in the strike. Okay, we can pass over. The next one will be the definition of the left off. Okay, so they are all okay, so we can go on with the processing, and the next step will be to save the results, so to save the processing by click on the save button, and the data will be ready to be loaded into the report. Okay, so now I can click on Save. And so the data are now ready to be analyzed by means of the report. So now I'm going to select one of the available reports containing the information about the GDS. I have also to select the normative band. All this information, all this data will be loaded automatically into the report. And as we got before, this is the standard report that is very, very similar to the one that we saw for the GDI, but in this case, on the third page, we will get information about the GPS index, that is the index which represents the overall the information about, the overall walking of the patient. In this case, I have considered a normal subject, so this data come from a normal subject. So as you can see, we have a very low GPS value. Consider that the GPS value is in degree. So we have a GPS value of around 4 or less than 4 degrees. So it's very low. And while if we have a look at which are the Gait variable score that we get for the right kinematics variable or for the left kinematics variable, we can see that also in this case, these values are given in degree. So if you look at them, you can see that the values are very low. So we are more or less around 1, 2, 3, maximum 4, 5 degrees. So this is what is expected for normal subject. While if I want now to show you an example about a clinical case, in this case I'm going to show you some data coming from a patient of 7 years with a spastic diplegia. This is the video coming from the patient before the treatment. So you have seen the video. Also from the clinical evaluation, the doctor signed out that the major impairment were on the right side. So these are the data coming from the 3D gait analysis for the patient. If we look at the GDI, we can see that the value is below 100 and that the lower value is for the right side. Remember that for the GDI, the lower the value is, the worse or the further the walking data will be in respect to the normalcy. So in this case, we get lower value for the GDI for the right side respect to the left side. That means that there is a major impairment on the right side compared to the left side. And now, so these were the results also about the GPS. Also in this case, the GPS, that is the global index, give us the same information basically about the GDI. So also in this case, we see that the index is higher for the right side compared to the left. Remember that these values are provided in degree. So the higher the GPS value is, the more compromised, the gait pattern is. So we basically have the similar information about the GDI. But if we have a look at the gait variable score, we can have a better understanding about where we have the major impairment. So for example, if we look at the value, we can see that we have a very, very high value for the GVS for the ankle. That is very high because it's around 55 degrees, so it's very high. After that, we have that the major impairment is at the level of the hip and at the level of the pelvic. And thus the major impairment are related to the right side. Now I'm going to show you about the video during after the surgery. So this is the patient after 2 years after the surgery. The patient has been underwent to a psoas lengthening, a lengthening at the hamstring, the rectus femoris, the transfer of the rectus femoris, and the lengthening of the gastrocnemius muscle. So this is her video coming from her gait analysis. Now I'm going to show you also the 3D data. So now you should be able to have a look at the 3D gait analysis. And here we have the information about the GDI. So we see that we get an improvement about the index that now increased from a pre-value of 1670, and now we got a value around 19 for both the sides. So it was a good result from a global point of view. If we look at the GPS value, we get more or less the same information. And if we have a look in detail about where we get the major improvement, we see that we really get a very strong result in terms of improvement for what concerns the ankle kinematics. In fact, we pass from a value of 55 to a value of 4 for the right side, and also for the left foot we get a decrease, a big decrease in terms of the Gait variable score value. Okay, so as you have seen in this example, and as it has been demonstrated by a lot of researchers, we can say that both the GDI and the GPS indexes are, let's say, enough sensible for measuring the functional level of limitation in patients with walking impairment. So now that you have seen how to use them within our Smart Clinic application, you can also start to work with them. I'm going to thank you, everybody, for your kind attention, and I hope to see you again on the next webinar session, and have a nice day.